My name is Tytti Hyrkäs, and I work as a building lifecycle and sustainability expert at Ground. In this video, I will briefly present the steps required to produce material inventory lists from building information models to efficiently and reliably perform a lifecycle analysis of a building. Building information models are typically designed to represent the geometries of building components. A lifecycle analysis, on the other hand, considers the whole lifecycle of a building, meaning all the carbon emissions occurring during the building product manufacturing processes, construction, the use stage, and the end of life. One of the key data sources needed for the analysis are building components and their materials. This information is often available in a building information model. Additionally, information related to material emissions and other life cycle stages are needed to complete the whole life carbon analysis. The data in the building information model can be effectively employed in the calculation of materials carbon footprint if the building parts can be identified by the classification and properties in the model, correct material quantities can be retrieved, and product information is included in the model data, or the building components are labeled in such way that the material properties can be retrieved from another source reliably. Here we present the practical steps to ensure that the data from building information models can be reliably extracted into LCA calculations. The process relies on EFC models that are exported from the native modeling software. As a first step, each element in the design model should be assigned the correct IFC class, predefined type, and other required properties. This allows organizing and understanding the extracted data in the later stages. The final report of this project displays how the IFC definitions can be mapped into various LCA reporting categories. As a second step, a project-specific product type designator, such as floor type 1, should be assigned to each element. This allows linking the structure's geometries to product and material data that is not recorded in the model. As a third step, quantity information is extracted from the model. Depending on the element type, quantity can be extracted as length, area, volume, or number of units. The final report of this project contains a list of typically used extraction units for different elements, but it is also important to consider project-specific modeling practices. For example, the volume for a certain element can only be extracted if the model contains reliable three-dimensional geometry. As a fourth step, the quantity information is transferred from the building information model to the LCA calculation software. In this stage, possible overlapping between design domains is considered, as well as possible missing information in the models. As a final step, any necessary product and material data that is not recorded in the model can be added to the information. For instance, in this stage, the element type designators can be used to link the breakdown structure or product information to the model data. In any project where there are multiple design models or several people participating in the process, the best way to ensure efficient calculation process and correct LCA results is to communicate the LCA-related information requirements from the beginning of the project. Additionally, any model aimed for LCA purposes should be accompanied with the documentation of what has been modeled, what is the level of detail, which building parts or details are excluded, and which properties are used to store the data.